Hi class, here's how to use subtotals in Python, and we'll employ these using accumulator variables. So what do I mean by subtotal? Well, let's say that you have a little program running and you want to keep track of the running subtotal. Maybe it's a program where the user is entering their monthly mileage in a car, or maybe they're entering some grades for tests, anything. Well, we can have a loop keep on going, but as it keeps going, we can have it always update the running subtotal. And here's how we do that. First, we use what's called an accumulator variable. Right there. Got to have an accumulator. And this is just where we're going to put the sum in. We start at 0. We're going to initialize it to 0. But then every time through the loop, we're going to get another number. Maybe it's 6, and we're going to add it to some. Get another number in the loop, add it to that. Another, add it to that, and keep going until it's signaled to stop doing this. So with our accumulator declared there and initialized to 0, then all we have to do, presuming that somewhere in here we're going to get a number from the user, just like look at any of the previous coding examples that we did this week. If we get entry somehow from the user, that's what we want to then add to the accumulator sum. So we just simply use this update expression here. And this is the same thing as this code, sum equals sum plus entry. And this is what's called an augmented assignment operator, sometimes called a combined assignment operator, where you get rid of this duplicate here and you combine these two into a plus equals, and then you're left with this, this, and this. So let's go to take a look at our notebook now and see what this is going to look like for us. I've got an example. All right, here is an example in our notebook. We're going to use this to keep track of monthly expenses. Imagine we're just running a little program where the user simply enters their monthly expenses. Maybe they are tracking their budget. Maybe they are reporting annual expenses, so they have to update their monthly expenses. And this code's going to help us do that. First of all, we are doing the same thing that we did before as far as having a while loop that will use keep going as its condition for continuing on the loop. So I have the exact same code here with while keep going equals y, and the code to update keep going based on the user's desire to continue or not. Now, we have a sum variable here, initialized to 0. That's our accumulator variable. And now let's just take a look at the 3 tasks that are inside of the while loop. The first thing is we will get that expense from the user. Make sure that you convert it to a float. And then as soon as we have that expense in our hand, we're going to add it to sum. Now sum initially is 0, so the first expense that gets entered is going to be 0 plus the expense, and it becomes the expense. So it all kind of works out. And then we have our prompt to the user. Do you want to enter something else again? Note then that after the loop is done, now we're indented back to the original margin, original tab stop. We're going to print out sum there. And by that point in the code, sum we've been adding to it with every iteration. And when the loop ends, we still have sum, and we can output it and see, well, what the sum of those values has been. So let's run this code and see what magic happens. I'm going to enter a monthly expense. And we're asked if we want to enter another one. I'll enter a lowercase y just to exercise the lower function. Here's another one. I'll enter another one. And how about one final one? I'll enter no here. And we do get the sum of 90122. Looking at those numbers, yep, that looks about right. But importantly, the functionality was intact. We kept going until the user indicated no, and then we just output the sum. Now, let's take this and elevate our code a tiny bit more. Are you ready? Here we have the sum. I wonder what the average of our expenses that we've entered has been. I wonder what the average has been. Well, we can't calculate it now, because an average is going to be the sum divided by the count. All we have here is sum. We don't have a count. We don't know how many expenses that the user entered here. So we need a way to keep count of the number of entries. So this next example is going to do just that. We're going to take that same code. Well, first, let me put a few spaces here just to get the spacing better. There we go. We're going to take this same code now. It's the running total, but we're going to add this time a counter variable. So we're going to have two special variables in this code. One is the accumulator variable for the sum. That's the subtotal. We're also going to keep just a count, and it's just like a bouncer at a bar clicking the little handheld counter as people go through. 1, 2, click, 3, click, 4, click. Well, we're going to make our while loop have a little clicker, and we're just going to count the number of times we've gone through. So this count is our counter variable, and we'll initialize it to 0. And then inside the loop, all we have to do, this is all the exact same code. That's the same, that's the same, that's the same. Just the only thing extra that we have to do is every time through the loop, let's increment the counter by 1. That incrementing will, of course, stop when the while loop stops. And at the end here, at the end of the day, or when this while loop ends, we will have a sum and a count. And now we can properly calculate an average, which is this right here. The average is sum divided by count. Note that I am formatting this to 2 decimal places, and I want a floating point output. And let's run this and see what happens. Here's the monthly expense. I'll do a few more of these. Yes, I want another one. Yes, let's do a big one now. Yes, let's do another big one. And finally, a no. And you can see here what, oh, that's a cool subtotal, 2222.2, completely unplanned. And then the average is 555.5. So again, to recap that, the difference was that we wanted to calculate the average. In order to calculate the average, you need both a numerator and denominator, a sum divided by a total. So we needed that total. So we just put in that counter variable and updated the count every time through the loop. Okay, now let's talk about sentinel values. Sentinel values. What is a sentinel value? Well, it's nothing more than just a signal to stop. It's like a secret code we can enter that's going to tell the interpreter, okay, we are done with our data entry. So how does this work? Well, first of all, we have to select a signal, select a sentinel. And frequently, if you're entering expenses, for example, expenses will generally always be a positive number. So it'd be safe to bet that, well, if you enter a negative number, that's never going to be actually one of the real expenses that was entered. So we could use a negative number, say -99. That'll be our sentinel. So we kind of describe it this way, and we put then in our while loop that as long as the expense here does not equal -99, then we're going to keep going in the loop. What this does for us is that it eliminates us having to use the keep going idea, and we don't have to get another keep going. We don't have to do that in our loop anymore. We're just kind of omitting that step because we've already got managed a way for the user to indicate their desire to stop entering data. So that's exactly what a Sentinel is going to do for us. Let's take a look at some code now. Here's a Jupyter notebook with some examples. Now we're going to do the exact same functionality that we just did in the last example, and that is that we're going to just have the user entering these monthly expenses, except this time we want to change it such that they enter a sentinel value, a special signal of -99 here to tell us that they're done entering data. So we need a couple of things to still. Our summing accumulator, our counter variable, because we still want to calculate the average at the end of all of this. This time, though, we are going to declare the expense early here. And that's just so that we have a value assigned to it. If we didn't do that, well, then the compiler would look at this line and say, wait a minute, I don't know what expense means. So if we had taken this out, we will get, some errors here because the compiler doesn't know what expense is at this point. So that's why before you use a variable, you need to declare it and at least initialize it to something. And initializing it to 0 is a safe bet in this case. That way, when we enter the first iteration of the loop, well, our while loop can actually intelligently evaluate whether expense is minus 99 or not, because it's holding a value of 0. And it can say, okay, 0 is not minus 99, and go on. All right, here is our input statement. And then note what I did. You want to be very, very explicit to the user what to enter and what to enter to quit. So that prompt there is a good prompt to the user saying, just enter your monthly expense or minus 99 to quit. Well, we do the same thing as before. We're going to then just sum that up, and we will sum up, or we will increase the counter every time through. So we'll be able to calculate the average. Okay. So let's run this now, and we'll get to see this in action. Here, I'm going to enter some monthly expenses. Bunch of those. And I'll enter minus 99 because I want to quit. And look at that. Our while loop stopped, and then we got some sums and some averages. So pretty cool there, huh? Now, there's an issue, though. Let me challenge you all to just stare at this and go, wait a minute, I think there's a little issue here with this code. Let me run it one more time. This time, I'm only going to have a monthly expense of $1, and then I'm going to quit. So because I had $1, my sum should be 1, and my average should be 1. But let's take a look at what happened here. It's saying that my sum is not 1, but minus 98. And then the average is all dorked up also. And how did this happen? Well, it looks like, it's supposed to be 1, but we ended up with minus 98. So somewhere in there, it subtracted 99. And that's precisely the way we coded it. We have to make sure that the minus 99 is never included in the sum, because it's a sentinel, it's a signal, it's not an actual value. So what happened here, the second time through the loop when we expressed our desire to quit, we entered a minus 99 there. So expense is minus 99. And then in this line, it subtracted 99 from the sum. And that's how we got those figures that were off. So we got to fix this. The simplest way to fix it is to just put a little tiny guard in front of this. Just like that. We're saying if the user wants to keep going, meaning they didn't enter a minus 99, and the way syntactically that is if expense is not equal to minus 99, well, then we can do the accumulator update operation, sum plus equals expense, and then we can update the counter. So let's run this code now. I'm going to do the same thing where I have 1 monthly expense and it's $1. Now I signal my intent to quit with minus 99, and you'll see here that those issues are all solved now. And we got the correct output there. So hope that this video helped you with accumulator variables, counter variables, and sentinel variables, and how to calculate a running total, and how to kind of make our code even sleeker as far as user friendliness and letting them enter more convenient values to indicate stopping the loop. All right, thanks everybody.